So the topic of the day is factoring x squared plus bx plus c term, and our coefficient in front of the x squared is 1. But before we get into the factoring or breaking this trinomial apart, I want to take a look at some multiplications of two binomials that we've already done. So we do FOIL on each of these and get the following answers. And I'd like you to look at some of the patterns that go on between the two numbers over here and the numbers that I'm underlining over here. So you'll see that on the left side we have a 2 and a 5, and we notice over here we have a 7 and a 10, a -3 and a 7, and you notice here we have a 4 and a -21. Here a -4 and a -6, and here we have a -10 and a 24. And here a 2 and a -8, and we have a -6 and a 16. And the question is, what's the relationship between the numbers on the left and the numbers on the right? And if you think a minute, you'll see that in each one of these cases that when we move to the factored form or the broken down form, we notice that these two terms add to this b number and multiply to this c number in every single instance. So 7 when we add, 10 when we multiply, +4 when we add, -21 multiply, and so on and so forth. So this is what we're going to look to do. We're going to look to take a trinomial with a 1 coefficient in front of the x squared term and factor it into two binomials where our two numbers are going to multiply to the c term and add or subtract to the b term. So let's do some practice. So again, I'm looking for two numbers that multiply to 12 and add to 8. Now, one thing you might want to do on this is just list the multiples of 12. And we have 1 and 12, 2 and 6, and 3 and 4. And then look at which one of those take and get you 8. This is the only possibility. So now what we have to do is take and write our binomials out, x in the front, and then I'm going to need a 2 and a 6. And in order to get a +6 and a -12 when I multiply, or I'm sorry, to get a +12 and a -8 when I multiply and then add, I'm going to need both these terms to be negatives. When I FOIL this out, you'll notice I get x squared minus 6x minus 2x plus 12, which is x squared, minus 8x plus 12. Done. So you'll see knowing your multiplication tables is really going to help. Let's do another one. Got 1 and 24. To get 24, 2 and 12, 3 and 8, 4 and 6, and that's all that's going to get you 24. I'm going to look and see which of those combinations get me a 5. This guy right here will do it. I'm going to list my binomials. The only way I get a 5 when I add is to have the 8 and the -3. That gives me the -24. And if I FOIL that out, it's going to check. Here we go again. We'll list the multiples of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. List the binomials. Find out which two get you 20 when you add, because they'll all get you 36. This gets me 20 here. And I think that's about it. So I'm going to put my 2 and my 18. I need positives on both. And that one's done. Again, go over here, 1 and 8, 2 and 4. Those are the only things that get me 8. And I'm kind of looking and going, gee, I need to get 5 when I add. Neither of these combinations get me 5. Therefore, we say this is not factorable. And another word for that is called prime. Let's keep going. These numbers are going to be a little more challenging because we don't necessarily know all of our multiples of 96. And you'll likely have a calculator to do all this. So again, let's start listing all those multiples. We've got 1 and 96, 2 and 48, 3 and 32, 4 and 24, 6 and 16, and 8 and 12. And we're looking for which ones get us a 20. There's one right here. This also gets us a 20. So now we have to pick between these two. Now, in this case, the only way I get a positive is by two positives or two negatives. So they have to have the same sign, which is going to rule this out. So really, I have to have minus a minus, 12 here, my 8 here, and that gets me my negative 20 when we add. Let's move over to the 144, list its multiples, 1 and 144, 2 and 72, 3 and 48, 4 and 36, 6 and 24, 8, 18, 9 and 16, 12 and 12. Again, I'm looking for two things that get me 25. I'll look, and this is looking like our only 25 option. X and X, I need to have both positives or both negatives. In this case, they're going to be both negatives. 9 and 16, and that gets the job done. Okay, so we remember back, we've done this before a little bit, that if we take two binomials, multiply them together, and set them equal to 0, we know, it's called a zero product principle, that either one of these two is going to equal 0. Either this guy equals 0 or this guy equals 0. So if we're asked to solve this trinomial equation, first of all, we can't isolate x because of the x squared. So we're going to take and factor this into a form that looks like the two binomials multiplied together. I need the multiples of 45. So that's 1 and 45, 3 and 15, 5 and 9, 6 doesn't work, 7 doesn't work. Then that's going to do it. So again, I'm going to look for my negative 4. There's x and x. I end up with a 9 and a 5. I need to choose the signs. So the 9 is going to be negative and the 5 is going to be positive. And this is going to equal 0. Therefore, since this product is equal to 0, either x plus 5 equals 0 or x minus 9 equals 0. Therefore, subtract 5 from both sides and get x equals negative 5. Add 9 to both sides, and x equals 9. And that's kind of like an OR. And there we have it solved. Do it again. Some more problems. I'm just going to eyeball this. There's two things I know that multiply to 99. First off, I get 9 and 11, and that's going to actually add to 20, so lucky first guess. Addition on both. Therefore, x plus 9 equals 0, or x plus 11 is equal to 0. Subtract 9, get x equals negative 9. Subtract 11, and x equals negative 11. So this is a little bit different problem because notice we don't have a side set equal to 0. Whenever there's an x squared in the problem, you want to first of all try to make that term positive, and then secondly, we're going to set a side equal to 0. So if I want to make this positive, I need to bring it over to that side, and I'm also going to bring this number over to the other side too. So I'll add x squared and subtract 21 from both sides, giving me x squared, list it in descending powers of x, plus 4x minus 21 is equal to 0. List my multiples of 21. I can, again, I don't necessarily have to look at all of them because I know 1 and 21 won't work, so I'm just going to try 3 and 7. That's going to get me 4. X. I need a positive 7 and a negative 3 to multiply to a negative and get me a positive 4. So x plus 7 is equal to 0. X minus 3 is equal to 0. Subtract 7 from both sides x equals -7, or add 3 to both sides, and x is equal to 3. Again, we don't have the x squared, or the side equal to 0. X squared is positive, so I'm going to bring the 3x over to this side by subtracting 3x from both sides. Remember, you can only add like terms. X squared and x are not like terms, therefore we have x squared minus 3x minus 28 equals 0. List your multiples that get you 28. I'm going to go with 7 and 4 right off the bat because that's what I see. We could list all of them, but if you know those multiplications in your head, this will come a lot quicker. I'll put in a 7 and a 4, and now I just have to pick the signs. I want a -3, so the 7's got to be bigger than the 4 in terms of negatives. So now we have x plus 4 is equal to 0, x minus 7 equals 0. Subtract 4 to both sides, get x equals -4, or add 7 to both sides, and x equals 7. So now let's go back to factoring. You'll notice that in each of these problems, I've added another variable to the problem. It's just there to kind of confuse you, but it's really no different. I'm still leading with a 1 coefficient in front of my squared term that leads. I'm still going to look to see what adds to 13 and gets you 30. 3 and 10, I'm looking at that right now. But the problem is I need a -30, so the signs need to be different. So I'm going to go to 2 and 15. All right, and use this guy. Notice though, when I take and do my product of binomials, I list my x first, my 2, my 15, giving the 15 the positive, the 2 the negative. That's going to get me a -30. But in my final multiplication, I need a y squared, so I'm going to put my y's at the end. Now notice what happens when I FOIL. I get x squared plus 15xy minus 2xy minus 30y squared. Adding like terms, these two are like, so I have x squared plus 13xy minus 30y squared, and it's checked. 108 is another one of those that we don't necessarily know all our multiples of, so let's go ahead and list them all out. We've got 1, 108, 2, 54, 3, 36, 4, 27, 6, 18, 9, 12. I need things that are going to get me 3. Here's a 3. And that's about going to do it. So I'm going to say I lead with A. I finish with B. And I need the 12 to be more negative than the 9. So I'm going to go minus 12 plus 9. I'll just do the FOIL. A squared minus 12AB plus 9AB minus 108B squared. Like terms are here, so therefore I have a squared minus 3ab minus 108b squared, which is what I was looking for. And that's going to do it. Again, the key is knowing your multiplication tables. If you don't know them, then listing all the factors and then looking to see what add to the numbers that you're trying to get to. Alrighty? Until next time.